Hey everyone, it is Mr. Vargas here, looking to help out my Math 8 class, and today we're focusing on homework 1.6 scientific notation from page 55 of our textbook. Let's go ahead and look at some of these problems. Number 1, we are asked to write each number in standard form. So here they give it to us in scientific notation. And we've got to change that thing to standard form, which just basically means we need to write it as a regular number. Okay, so I locate my decimal point. That's the first step. Then I go and determine what power my 10 is being raised to, and that's to the third power. So all that means is I'm actually going to take my decimal, 3.16, I'm going to take my decimal, and I'm going to move it to the right 3 times, because that exponent is 3. So I'm going to move over 3 place values. Ready? 1, 2, 3. Make that new decimal. And you can go ahead and fill in the gap with a 0. So this is just 3,160. Another way to think of that is if you have 3.16 times 10 to the third. Well, we know that 3.16 times 10 to the third power would be 1,000. And when you multiply that out, you will get 1,000 times 3.16, which is equal to 3,160. Easy peasy. Moving right along. Number 2 now, we've got 1.1 times 10 to the negative fourth. First thing I do is I locate that decimal point, then I determine what power I am being raised to. And here I have it to the negative 4. Whenever we have a 10 to the power of a negative number, we're actually going to move our decimal to the left that many place values. So here we go. I've got 1.1. And that 4, that negative 4, tells me to move it to the left 4 times. So it's going to go 1, 2, 3, 4. And you make its home right there. Fill in the remaining empty spaces with zeros. And there we go. So I can put another 0 on the left of that decimal. It doesn't change the value. So 1.1 times 10 to the negative fourth is 0.00011. All right, moving right along. Let's go ahead and look at number 4. And here you are asked to write each number in scientific notation. So they give us the regular number, and they ask us to write it in scientific notation. First thing you do is you change it to a decimal number. So I'm going to put a decimal 0 behind it. Alright, and now I'm going to move that decimal to the left until I am left with one number in front of the decimal. And here's what I mean. Take this decimal, I'm going to move it to the left, that's 1 time. Move it to the left again, that's twice. Move it to the left, that's 3. Move it to the left, that's 4. And I'm going to stop right there. Because now this number right here, 4.3 is actually less than 10. And if you remember in that music video that we watched today, we want our number to be bigger than 1, but we want it to be less than 10. So we take 4.3 and we write times 10 to the, and then we can go ahead and we can count how many times we moved it. That was 1, 2, 3, and 4 spaces. So 43,000 is the same as 4.3 times 10 to the fourth. And that is your answer. All right, number 5. Ooh. Okay, here we go, number 5. And this problem is now a really, really small number, 0.0072. And we are trying to make that number into scientific notation. So I'm going to actually find that decimal, and I'm going to move it so that it lands right behind the very first non-zero digit. And here we go. And that's 1 space, 2 space, 3 spaces. And there it goes. It lands right in between there. And 7.2 is definitely less than 10, but it's bigger than 1. So 7.2 is good to go. We can write 7.2 times 10 to the, and now we got to figure out, well, I moved it to the right this time, 1, 2, 3 to the right, so actually this time it's going to be a negative number, so it should be 7.2 times 10 to the negative third. And we'll always use negative exponents when we are working with really small numbers, with numbers less than 1. All right, now let's go to number, let me take a look at number 10. Sorry, number 9. We're asked to make a true statement, so which one is bigger than, or is it less than, greater than, or equal to? So we've got 678,000, sorry I can't speak today, and we are asked to find out if that is less than, greater than, or equal to 6.78 times 10 to the 6th. Alright, and what we need to do is go ahead and convert this number on the right hand side into standard form, or into a regular number. And the way we would do that is we'd find that decimal, and we're going to move it 6 times to the right. Since it is in the positive, since it's a positive exponent, we're going to move it to the right. Positive goes to the right, negative goes to the left. So it would be 6.78. And let's go ahead and move it 6 times to the right. Ready? 1, 2, 3, 4, 5, 6. Go ahead and fill in the gaps with zeros. And you can put that decimal right there, right at the end. So here this number is actually 678,000, and that is the same as 6,780,000. And 6,780,000 is definitely greater than 678,000. Okay, last one. Let's check out number 8. Word problem. Sorry, we're jumping back this time. Number 8, the space shuttle can travel about 8 times 10 to the 5th centimeters per second. It is more appropriate to report this rate as 8 times 10 to the 5th centimeters per second, or 8 kilometers per second. Explain. So this is more of a question that's basically asking us which measurement is better. And you can think of it, we've got a space shuttle, right? And space shuttles are really large objects. And since it's a large object traveling through space, we probably want to talk about how fast it goes in terms of kilometers. So like 8 kilometers per second is definitely more appropriate. It's more meaningful. Than talking about the spaceship going 8 times 10 to the 5th centimeters per second. Maybe if it was like an ant, then we would talk about how many centimeters it could travel per second. But since it's a big ship, big space shuttle, we definitely want to use the bigger measurement. All right, and that's it for today. Good luck on your assignment, and I will see you tomorrow.